If you could count for a year, would you get to infinity or somewhere in that vicinity?
Combinations are pretty important to probability, but let's just see an example. It's the best way to describe it. So how many groups of 3 can be selected from A, B, C, D, and E? Well, we kind of looked at this in the last class. You have 5 choices for the first letter. Then for each choice of that first letter, you now have 4 choices, and once you've made that next choice, you have 3 letters left. So that's really how many different combinations can be made. But as you can see, we get A, B, C, we get all these different letter permutations. But what happens if we don't really care about the order? So the previous answer works if you want to know the order, but if you get, let's say, 5 cards, you don't care about the order in which you get the cards. You can rearrange them in poker, let's say. So all these 6 answers would actually be part of one group, and really it's just one group rearranged 6 ways. And as we saw in our previous example, permutations, this is really just 3 factorial, because there's 3 factorial ways of rearranging this group. So once you have all the answers, all you have to do is divide by 3 factorial, because that's the ways of permutating the groups. And you would get the answer 10. You could make 10 different groups of letters. So just to generalize the idea, if you have n items and you want to know how many groups of size r exist, well, this is just as the equation says, n times n minus 1 all the way down to n minus r plus 1. And you can really work that out for yourself, and it should make a lot of sense based on the previous example. But this means order matters. What about when order doesn't matter, as we were talking about before? Well, all you have to do is divide by r factorial. So really, knowing the number of items and the size of your group, you can get the number of groups really easily. But this numerator is kind of complicated, so we can actually simplify it. If you had n factorial on the top, and you divided by n minus r factorial, you can kind of cancel out those the numbers in the numerator. And this will make it a lot easier for your calculator, which has a factorial button, instead of plugging in all these n times n minus 1s. You should be able to see from here how the first equation gets to the second, and how you get to the third, and how it really does simplify. I wanted to make that really crystal clear, because a lot of people may jump ahead. Now, n choose r, that's how you pronounce this, is n factorial over n minus r factorial times r factorial, and this is the number of possible combinations of n objects taken r at a time. And you really do have to remember this equation if you can. So from a group of 7 men and 5 women, form a committee of 3 men and 2 women. How many possible committees are there? A really simple example. So 5 women, and you have to choose 2 of them, times 7 men, and you have to choose 3 of them, and you get 350 different committees. And that should be easy. Now, the next problem is really more of a complication. So what if 2 of the 7 men won't sit on the committee together? How many groups of members, or how many committees are possible now? Leave a video response or a text comment of the answer. If people really want me to make my own, I can. Now, if you haven't gotten the idea, I really tried my best to explain it. Go back to the original example, A, B, C, D, and E, and really work through that one on your own. And that will hopefully get you crystal clear on this. And that's really the basic idea of groups.
When you know, what's the chance it will snow when you bet? And you end up in debt. Oh, try as you may, you just can't get away from mathematics.